well, I didn't my life. And of course, I can really
Yeah, I mean you can. I think Rick might.
give you an SD card at the end of the day, or you can
Anybody volunteer to do the intro? Rick, may we do the intro? Are you going to do the intro?
Let Rick do the first intro, and then you can intro me after the first intro.
Hey, good evening, everybody. Welcome to CreateInTO. Thank you all for coming out to our first gathering for the fall. And I'm going to hand it over to Dan because I think he's eager to go.
I have an intro, man.
You have an intro. All right. There you go. Oh, you Ladies and gentlemen, the one, the only. I'm not sure if you're ready for him. I can't hear you. I can't hear you. All right. It is the one, the only, the man, the legend.
Wait. Here's the name.
Dr. Abstract, aka Dan.
Just Dr. Abstract.
Okay. Dr. Abstract, here, live, in person, at Handlebar. Give it up for
You're going to dub it out.
Dr. Abstract.
Yeah, thank you. Standing ovations, I can't believe it. Hello, welcome. I am Dr. Abstract. Do you like it? It's the new one. All right. Dr. Abstract, and the talk is Abstraction in Teaching and Teaching Abstraction. So abstraction, what is abstraction? In general, it is when you say in general. So it's taking the specifics away, abstracting the specifics, and generalizing. Here we have the details that have been taken away, such as the wrinkles on the towel. And this is called Focuso. It's an abstract photograph by Hollander Maui. And so it's abstract art. The wrinkles are gone from the towel, it simplifies it. The wrinkles are also gone from Dan Zen's wife here, which is great. And it creates a beautiful simplified aura here on the sands. A picture is an abstraction itself because it's not real. So you've taken away all the three dimensions, all the real things, turned it into a picture. Here's another abstraction of abstraction, this box. It's quite abstract, and this word even is an abstraction, because we've taken away the details of what's in abstraction. However, we've applied them here. So abstraction has there's two different types of abstraction. Funny story, I was preparing for this. Did you read the abstract of the talk? No? It said, what is abstraction? 2 types. And I wrote these notes for it, and then I summarized my notes, and I lost my notes. And I had this epiphany about what abstraction was, that there were 2 types. And I lost my notes, and I couldn't remember what the 2 types of abstraction were. It's like, oh, okay. Because it's kind of neat. When you abstract something, you take away the details, but in doing so, here are the details over here, left over here, and those details actually are quite abstract. If you take away, say, the number of something, and just say in general it's this, you take away the numbers, those numbers are also very abstract. They have no context. So I was going, okay, is that the 2 types? It's like the thing that's abstract, and then the things you take away are also abstract? I don't think it was that. I was doing a creativity framework, or a philosophy of notism, which all this comes from. And it took me 10 years to do that, or so. 8 of those years, I was talking about hierarchies without realizing there were 2 types of hierarchies. One is composition. So over here, yeah, good. One is composition, where you have a part of something, like several parts. And these are connected with ands. So in composition, you have part and a part and a part, etc. And over here, we've got classification, which are ors. So that's a type of thing. It's this or that. It could be a square or a circle or a triangle, etc. Abstracted, those are shapes. So that's classification. And so when I had these two different types of hierarchies, I realized, well, if abstraction is just going outside the box here, or in other words, check this out. If we take a dot, that's called a node, and put it at the center of this box, and bring it down to the center of these other boxes, and to the center of those boxes, we get a traditional hierarchy diagram. So abstraction is when you move up the hierarchy. So if there are two types of hierarchies, one for composition and one for classification, then perhaps that's the two types of abstraction that I was thinking about. So I went, okay, I guess that's good enough. That must have been what I wrote in my notes that I lost. So let's give an example of these two types of abstraction. Here's abstraction to composition. When in code, composition is basically your statements. So here's one thing, and another, and another. So we've got 3 circles. This app is composed of 3 circles. So for compositional abstraction, we say, well, actually, what do these things have in common? So we kind of factor it, and we say, oh yeah, they're all circles. These are the specific details. So we abstract the details, put them in an array, and we're left with the general circle here, a new circle. And then we can use a loop, which is a convenience function for handling abstraction. And inside here, we can place the specific details. So that saves code, especially if we have like 100 monsters or something like that, and all of a sudden we've just got 3 lines. Here's an example of abstraction in classification. It's similar. In our code, we've got a bunch of statements, which is composition, but we decide that this is something here that we're going to use. We see it again here, and instead of doing it in the same place twice, we abstract that out to a class. Could be, this was code to make a button, and then we had to make another button, so we had more code for that, and we realized, oh, you know, this is an object, a button. Maybe if we make a class of that, then we can create objects from our classification, from our abstraction. And we have, again, less statements on this side. So the advantages of abstraction, I think, are well known. Especially even if you haven't done code, well, there's lots of advantages in the real world of organization, basically. But if you haven't done code, you may have done CSS, HTML, and that is very much abstraction. You're taking the design elements out of the HTML, abstracting them to another level, the CSS. And you find that that's very efficient because you don't have to repeat it. So you can do it once, and that makes it efficient. Change it in one place. It's also consistent. Because you're changing it only in one place, it's consistent. Now, it could be consistently wrong, but let's hope not. So, and usually that comes down to here. We'll get to that in a second. So, in doing so, in making less lines of code, etc., it simplifies it. Hopefully, it also makes it more clear. Those aren't always necessarily the same. If you choose a really bad word for, well, not a bad word, damn. If you choose a non-clear word for your class name, it might not be clear, but usually it simplifies and clarifies your code. You're seeing less stuff. And it's well tested. Bing! So it can be well tested. If you're using it over and over again, then it has the test of time. And many people who make libraries and publish libraries for people or frameworks, etc., they've tested that code. Whereas if you go and make it yourself, it may not be quite as well tested. So those are the advantages of using abstracted code. The disadvantages are it can be inflexible. Unless lots of parameters are provided, you're sort of stuck with what you had made before or what you've got. And so it could be inflexible. It also can lead to a monoculture. In ZIM, which is the software that I use, it's abstracted, and we'll introduce that in just a bit. There's this, it's a component that it doesn't spin. It's got 3 little dots. Go dot, 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 dot. Oh, that was 4, wasn't it? Dot, 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 dot. It's not a spinner, because it's not spinning. And also, there's already a famous component, well, now famous component called a spinner. Remember in the Apple early days, there was that, oh, the nice number picker, that, like a date picker, and it goes... Don't you love that? That's called a spinner. So I didn't want to call it a spinner. It's not a progress bar, which, you know, progresses. It just goes over and over again. So I call that component a waiter. Nice, huh? It's a component which is a waiter, and I think that's a great name. You guys should run with it. A waiter. But because we have abstracted that code and sort of made a waiter for people, it leads to this monoculture. Now everybody who makes ZIM or works with ZIM, I go look at their app, and what's the first thing to show up? This exact waiter going, I go, okay, that's ZIM. But you know, that's kind of annoying, and sometimes monocultures are... It's kind of the opposite, monoculture, to consistency. Well, or is it the same? It's the same. But note that it's good and it's bad. So you have that guy, what was his name? Not Leslie Nielsen. Jacob Nielsen. Yeah. Leslie, that would be good. I think there should be like a play on that. Jacob Nielsen came along and said, no, all your components should be the same forever, and that way we get to use them easily. You know, there's welcome HTML components that haven't changed since 1995, except for styles, which is good. So anyway, it can lead to this monoculture, not a multiculture. Given, I didn't know quite what to put here. Abstraction, it's already done for you. So if people are using a ZIM button, for instance, then this has ramifications when you're teaching. As I teach, they don't really get to see how to make a button because it's already done for them. So that's a little bit of a problem from an educational standpoint. You have to pick and choose what you're going to teach. How far down are you going to go and teach the basics? So that's what the next slides are about, is that kind of stuff. Stagnation, really the same as monoculture. Things haven't changed in a long time. Unzen, what do you think of that one? Unzen, oh, how could that be? Yet on the other side we've got simplicity. Isn't simplicity Zen? What do you think? I know this guy Dan Zen, and he thinks about Zen a lot, which is kind of funny, and he is adamantly not Zen. So why is that? Now, we're talking abstraction here. Abstraction to a certain degree can be used by Zen to tell you what not to do. With Zen, you're not supposed to concentrate on classification of things. You're not supposed to say, oh, there's a tree, and there's another tree. You're supposed to say, look at each leaf on the tree. Oh. Be there in the moment. See the specific details, not the abstract symbols. So I kind of said, really? Okay, well darn, I guess I'm not really Zen because I love abstraction. I love it because it lets us think about perhaps deeper things. You know, we don't have to spend time looking at each leaf. There is a time and place for that. And that's one nice thing about abstraction and knowing how to work your way up and down a hierarchy is you can pick and choose. You know when to go to the specifics or when to go to the abstract or the general. So anyway, there are some pros and cons to think of. Ooh, so these are now programming layers, as in computer programming languages. And if we're going to teach, if we're teaching anything, we can think about what level of abstraction do we want to teach it at. But here we're going to use teaching creative coding. So let's start down here at the bottom. Node 0. Ooh, because coders start at 0. So this is now the hierarchy flipped upside down. So we've got node 0 at the bottom. And then we have these zeros and ones. So out of like the universe came these zeros and ones, or on-offs, or they're not there. Or is it yin-yang? Who knows? It's just these two things. A wave going up and a wave not going up, or whatever it is. And with those things, with those zeros and ones, some language came along. I'm not sure if it's exactly machine language, but they sort of took them and organized them a little bit and said, here, use that to, you know, add things. Here, use this to subtract things. Here, use this. And they gave us a few abstractions where we didn't have to worry about the details of how to do that with the zeros and ones. They worked it out for us. But that wasn't very helpful. I mean, to a certain degree it was. It's helpful to the next language up, which might be C or some other language, whatever. Some other language here said, oh, okay, well I like those, but I do this, this, and this quite often. So I'm going to collect those and put them here. And I do this, 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 and this, and this, and this off, and I'll collect them and put them there. Then these two things I'll put there if you join them together, and so forth. So now we've got a bunch of higher level functions or functionality here that we can use. We don't have to worry about the details. They've been abstracted away. So then JavaScript comes along and says, yeah, we like this stuff. We have to work with the browser, so we'll combine it with some other things. We'll take these little bits and we'll make all of that stuff for us. So this is what JavaScript provides. Then they said, here's the canvas tag, and we give you how to make a shape. It's like, oh, thank you. So CreateJS came along and said, and other libraries like, Pixie, that's it, yeah, Pixie, and those guys. So they came along and they said, all right, you can make a shape, but here's how you can organize those shapes in containers. So they gave us classes like a container and other things like that. They also gave us events, other things that we do quite often, and now we don't have to think about how to do that stuff. So we're up one more level. But they didn't give us a button. They didn't give us a slider, a dial, all these components. And to be able to drag, we had to do like 5 or 6 lines of code, and sometimes it got even worse than that if we had to apply a boundary, and all these kinds of things. So ZIM came along and gave us conveniences, so we have one line drag and drop sort of thing. We've got the components. We have the ability to do parallax really easily. So all the details of that have been abstracted out. So that's that. Then Scratch came along, not on top of ZIM exactly, but Scratch came along. You may have heard of that. And we're talking teaching. I am moving into teaching kids, and Scratch has been used to teach kids, where we abstract even typing. So that's been taken out, and now we just choose from a menu, a plug and play. We just snap things together. So that's sort of the levels of abstraction that we could teach in. And now I'm going to show you some examples of doing so. A little bit hard to see, but there's a console down here. Whoa, so this is Java. Now we didn't start way back, computer science may look at other things like how to make machine language and stuff like that. We're just starting with Java in a console. Now you type some code in here, you look at the words or the numbers that come up in the console. It turns out that at Sheridan, we teach computer programming. We teach interactive media as well, and that's something that I do. But at Sheridan, we teach computer programming, and those computer programmers do not see anything beyond a console until 3rd year, when they get Java effects or something like that. They see no shapes, they see nothing except words and numbers on a console. So I've put a little rating here, and sorry for the blown out projector. There's various guides and colors in here as well. But anyway, it's basic. So this is basic. 5 out of 5 for basic. I don't think it's very fun to see just words. Now it is to some degree fun if you're really into words and numbers. But if you're at all a visual learner, it's a little bit low on the fun level. And then you've got the easy level. Maybe it's easy, but I wouldn't put a lot of the stuff they're doing necessarily is easy for people. You know why it's not easy? Because it's not very fun. All right, it might have been easy, but I am so bored of this. Unless you're really into that kind of thing. So next, we could teach on the DOM. And this is where a lot of places like Canada Learning Code and those kinds of workshops, unless they're teaching some other specific language, but if they're teaching JavaScript, most likely their output is here on the DOM. There is, believe it or not, like a browser window there. You can't see it because the colors are gone. But anyway, a browser window saying, hello world. Really, this turns out to be, to some degree, just sort of a glorified console. Oh, we can make the words bigger, and we can add color to them. And that's sort of where a lot of that learning in JavaScript on the DOM kind of happens. So it's still basic. I still don't consider it very much fun. It's sort of neat because you can make things that the rest of the world are making, like these info sites. They see, oh, look, I made an HTML page. Ooh, ooh, ooh. That kind of thing. Relatively easy. However, if you're learning JavaScript, I haven't said it's very easy, because if you're learning JavaScript on the DOM, what you're dealing with are things like, are you ready? Document.getElementById. Document.getElementById. And before you could even get that ID, you probably got a window.addEventListener, quote, DOM content loaded. All right, I don't really consider that very much fun. Whoever named those things are out of their minds. Console.log. I mean, at least it's a bit better than Java, which is what? Syst outline printers or whatever. Anyway, I wouldn't call that all that much fun, to tell you the truth. So, next. I like that. I should add that sound effect to my slide. The canvas. Here we are, blowing up asteroids that are spinning in space. First lesson. First lesson on the canvas. We're blowing up asteroids, sound, animation, etc. That is fun. All right, we're still working with the basics of programming. Still the same conditionals, functions, loops, arrays, all that basics, but we've got a visual output there immediately for us. Easy. One thing, it could be easy, but the neat thing about this is all of a sudden there's a whole bunch of really cool stuff we can do. So the ease goes down a little bit because you're all of a sudden, particle emitter, cool! So there's that aspect to it as well. Now you can take that and wrap it up. It's kind of funny. I did teach ZIM to some kids, and I gave them a zip file. That's how it began. Here's a zip file. You use the template in there. 20 minutes later, they've unzipped their zip files. I was like, oh man, that's good. Yeah, it's not bad. I really know how to take them through unzipping. Anyway, the next one I went is here, press this button and it will copy the code for you. Then put it in an editor. And they went, Notepad? We don't have an editor. So hey, okay, download Atom and then paste it into the editor. And then finally we kind of went, all right, maybe we just do this. Maybe in the browser, we put a place where you can just start typing your code, hit the word test, and there it is. And so that's where we're at now. So this becomes pretty easy. I think it's a lot of fun if we gear things towards like these things right here. Really easy to do this. We can drag them around. We can change the shapes of these wiggles, that kind of stuff. So there's an online editor version. Then you could teach in an IDE. So do you recognize this one? Underneath that thing. Whoa, that's Adobe Animate, once called Flash. And I did a lot of teaching in Flash throughout the years. You've got a timeline here, you've got your code window, there's a stage where you can place things. And then when you place them, you get these panels that you can control. You can also draw things in here. So what I found with the ease is I dropped the easiness down a little bit. As soon as you've got all that stuff, really what you've got are two apps in one. You have kind of like Illustrator or Photoshop where you're drawing stuff, and you've got a scripting world. And people spent a lot of time just trying to figure out how to name their instances, and there was a bit of a disconnect between the names here and the code. And sometimes in code we would make things dynamically and sometimes we wouldn't. And just getting used to the timeline and stuff, all that was also a little bit difficult. It did make creating assets a little bit easier because it's just drag and drop. But it was, like I said, a bit of a disconnect between that and the code. I find that if you just start coding and say, look, here's a nice, easy way to get your asset. For instance, check out this. Right here, you can't see it very well, but it says new label, and it says make the text welcome ZIM coder, make the color this, make the background color this, etc. So that's called an object literal, and we're just putting the property name and the value. That is code, and what we've done is we've abstracted that to over here, to a panel, where we're just taking the same things, text, text, but here you can enter the text into a field. And then look, here's a color picker that picks the colors. So it was really weird to create ZIM and build all these shapes and see these object literals listed one line after another and went, oh, that's what Flash did. They just made a panel that sets these values right here. And then you kind of wonder, do you really need the panel? So I looked at this abstraction, I started making it, and I went, actually, I don't really like it. I want them to kind of stay in code. Because if they can do the easy things in code, then they get to move towards the more difficult things with the same format or with the same type of stuff we're using. So I like the single system of code. Anyway, that's a choice that I made. So there's your values on the IDE. We move to the last one now. A thing called Scratch, which I haven't really used, but I think I'd like to try, I suppose. Has anybody used it out there? Did you grow up using it? Ah, nice. Or teach your kids using it? So it's plug and play. You pick from the menus, the various things, and you drag them over here and plug them in. So now that's abstracted the actual coding as well. Not just the properties to a menu, but actually if we're using conditionals, an if statement, or a function, these types of things, loops, etc. And they've abstracted them into little menu structures here. Now I did drop the basics quite a bit on this. I maybe shouldn't have, because these basics are actually here. They're nicely grouped, and you can kind of easily see, oh, here's a bunch of loops. And that is a way to see the basics. I dropped the basics just because we're not actually coding, so maybe the basics of typing this stuff is necessary. Now, I'm almost feeling bad about that. You know why? Remember Word and WordPerfect? The code in behind that, people would say, oh man, you know, you got to use these tags and stuff in behind here. Why are you going to this WYSIWYG editor? You know, and then what happened? WYSIWYG editor just took over. So it may very well be that I'm one of those Luddites saying, no, 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 you don't want to code this way. It's not the basic coding. And then give 10 years from now, everybody will be coding this way. I'm not sure. Grown-ups are coding kind of this way. This is node-based coding, where you've got these boxes and menus, and just dragging connections between various things. So when you use this, it can get quite complex looking, but on the other hand, so can code. You can look at code that's been made and look at it and go, whoa, that's a lot of stuff. Now, as you're coding, you know what you're doing. You're building it one little bit at a time. It's all very straightforward. Building one bit at a time, and then you step back and look at it and show your mom, and your mom says, wow, you know. And it may be the same thing with this. Perhaps as you're building it step by step, it doesn't seem all that complicated. But if you look at a complete one of these things for, you know, a larger app, it's like a rat's nest. It's just everywhere. So who knows? The jury's out on these, but this is sort of the highest level of abstraction, and presumably it's fairly easy to do. I have dropped the fun. Now it's supposed to be fun. Oh look, there's a little flying kitty, and you know, how could it be more fun than that? And what I'm thinking is this. I'm thinking that people who are in their, say, their early teens, that kind of thing, maybe growing a little bit too old for this sort of feeling, are saying, I know there's more out there. I know there's this magic stuff called code. I really want to do that. This is okay, but I really want to do the real thing. So I dropped the fun level a little bit and thinking about them saying, yeah, it's fun, but you can get enough of it, I think. All right. It also gives you certain things, elements that you work with. It tends to be a bit more, here, use this. And that can limit your fun as well. So the last slide, teaching abstraction. So this is when we might actually teach abstraction. We've talked about abstraction, we've talked about the different layers of abstraction, and obviously, depending on who you're teaching or how you want to teach, maybe, you would choose different levels there. There are different advantages that I mentioned as well, you know, with the funness and the easiness and the basicness. But here is sort of when I teach abstraction. I teach it in line, so all the time while I'm coding. Now these work across this way as well. So we're doing where, when, how, and why. So I teach it in line all the time when I'm coding, I say, hey, look, this variable is not the thing, it's a representation of the thing. And some people even have a problem with that type of abstraction. So I use things like, oh, it's like a label on a Tupperware container and these types of things. Functions and loops are also used for compositional abstraction. And the reason why we do this is it simplifies our code, it makes it more efficient and more consistent. And I think as we're coding, they see that. Oh yeah, I don't want to do this a whole bunch of times. I want to abstract it to one place and then provide the details. I get it, it's simpler, or what have you. After a while, once they've recognized, once they've experienced abstraction, then you should do a lesson on abstraction. So this is when we introduce the hierarchy. There's a creativity framework I'll give you a link to in the next slide. And that creativity framework lets you move up and down hierarchy. It talks about the node. The node is there. Do you know what's up above the node and what's down below the node? Down below the node is its content. Up above is its context. Also parents and children. Also super and sub. So a whole bunch of definitions of how hierarchies work. These are these underneath, those are the aspects. So you break things up into its aspects. Up above you get a perspect. When you break things up you analyze. When you join you synthesize. So all of these sort of definitions clearly laid out based on hierarchy. And then that also helps you with levels of abstraction and seeing these isomorphisms of hierarchy. In other words, mappings across organizational systems. So that's what I teach in here. It helps us organize. We even see that, yes, those boxes, if you just remove the sidelines of the boxes within boxes, you get the format, if you put brackets around it, the format of HTML, XML. So that's just a different way of showing the same hierarchy. Remove the bottom lines and you get bulleted lists. That kind of thing. So them knowing that, hey, the HTML that they're making is actually just a representation of their wireframe diagram is good for them. They also get to see nesting. Nesting so that when they code, they keep their nesting and they understand that they're just making boxes inside their code. So this is the type of thing that we're getting when we come to that. Also helps in life. Don't know if you just put letters on the bottom of all those hierarchies and then you put delimiters for the splits, that is information. That's what information is. That's another word for code. It's another word for language. And if you make all these things round, boxes within boxes, they look like cells. A group of cells is an organ. And we're organizing. And the code for making cells is called DNA. These kinds of things. And our mind works in this way. Hierarchies lead to one place. What one place do we have in our mind? Consciousness. Interesting. So these types of things, very philosophical as well. Once we've done a lesson on it, and maybe a whole term, we have been working with the things that we're given. We've been working with the given abstractions, the classes and so forth of modules or what have you. Now it's time to help them make their own. So we introduce a module after the basics that lets people make their own custom classes. And we extend and do libraries. And for that, it's really a good thing to know the difference between composition and classification. And these types of the hierarchy diagrams and stuff like that help with that as well. So this is how I end up teaching abstraction. We talked a little bit about what abstraction is. Here's where you can find that creativity framework. Also in ZIM Kids is now where we're teaching kids, and that's been abstracted from school, which is more for high school people, more information, which has been abstracted from the general learn section. And then I also teach a shared and interactive media. Thank you very much. Thank you. Thank you, thank you. And thank you very much, Rick, and the whole CreateInTO team for having me here on this, what is it, an educational for coding, creative technology? Creative technology night here at the Handlebar in Toronto, Ontario, Kensington Market. Yes, Canada! Woohoo! Hello, world. And we'll end it there. Goodbye, world.
Oh, Matt made it. There's Matt and Demi, they're hanging. Matthew, hey. A couple of the students came in. There's Gabriel, Vindays, right, Troy, who introduced me, and Wesley's over in the corner. His company, or he's probably out smoking now. His company just got bought, so we're here at the Handlebar. All the best.